the results were indisputable. The amphibolites are 4.28 billion years old, 200 million years older than any other rocks so far discovered. They are the closest anyone has come to finding Earth's original crust.
These are the oldest rocks in the world, and it's amazing when you stand on it. You can try to imagine yourself almost 4.3 billion years ago when the Earth was so young and just barely forming. Walking on this landscape. And it's a really amazing feeling.
These rocks are now yielding clues about the thickness of the early crust. O'Neill has found unusual minerals which can only form in conditions of very high temperature and pressure. They prove that the amphibolites were made at least 12 miles down in the crust of the Earth. This means that more than 4 billion years ago, Earth had a solid crust at least 12 miles thick. And a crust that thick suggests there must have been continents. And there's more. Evidence hidden in the amphibolites reveals that these rocks must have originally formed deep underwater.
Well, you have to understand that when rocks form, they can record their chemical signature. And depending on where the rocks are formed, in what geological context they will be formed, they will carry that specific chemical signature.
The chemical signature of the amphibolites is unique. It proves that when these rocks formed, Earth had not only a solid crust, but oceans.
The signature we see here, it really looks like an oceanic floor. That means there was an ocean and a lot of water already at 4.28 billion years old. So it totally changes our view of what the Earth was like before.
To the scientific world, this idea is dynamite. But O'Neill is not on his own. There is more evidence to back up his claim. In the same ancient rock sequence, geologists find another unexpected rock type called banded iron formations. These rocks are made up of alternating light layers of silica and dark bands full of a mineral called magnetite, which, as the name suggests, are rich in iron.
We usually use a magnet to try to find these minerals. It's a quick and easy way to identify for sure those rocks as banded iron formation.